Hi, today we're going to talk about section 8.5, using the distributive property. And many of you already know what the distributive property is. It's something that looks like this, where we take the number outside and we multiply it through to get 5x plus 15. Okay, well today we're going to do the reverse of that. And there's a special name for that. It's called factoring. We're going to take a polynomial expression and we're going to factor it apart. We're going to break it apart into different pieces. And today, the one that we're going to talk about is this one, factoring out the GCF. And what GCF stands for is the greatest common factor. Kind of another way to think about that is what is it that goes into all of the terms? Okay. So today what we're going to do is we're going to kind of start with this, okay, and we're going to try to break it apart into those two pieces. And kind of the gist of it is, if I look at 5x plus 15 and ask myself, what goes into both of those? Okay. And if you look carefully, I think we can take out a 5 out of each one. So when I do that, I write that 5 out front, and then I just divide each of these by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. So it's doing the distributive property, but in reverse, going backwards. And one thing that might help you a little bit with this is your factor sheet. Okay, if you're not quite sure what goes into both 5 and 15, if you look at 5 and 15 on your factor sheet, and look to see what numbers is on both columns, what numbers are part of both of them. And that's what we take out in front. Okay? So let's take a look at a couple examples here. And right now we're just going to concentrate on breaking it apart. Okay? I have a few of them here. If I look at the first one, 16x squared plus 2x. What I do is I treat the numbers and the variables separate. So I look at the numbers 16 and 2. Do they each have something in common? What can I divide into both of those? Well, I can take a 2 out of each one of them. So I'm going to take out a 2. Okay, I'm going to leave a parenthesis. And now let's look at the x's. There's x squared and x. Okay, and if you remember, x squared is 2 of them, and x squared is 1 of them. I need to be able to take the same number of x's away from both terms, and I want to take the most that I can away from both terms. Well, this one only has 1 to take out. So the most I can take away is 1 out of each of them. Okay, and if I take this one away and this one away, okay, that means this one only has 1 left, and 16 divided by 2 is 8. With 1 x left over. And if I take that x away, and I take the 2 away, well, 2 divided by 2 is 1. Okay, a common mistake that a lot of people make is when they take everything away. When I divide out a 2, it doesn't turn into a 0. It turns into a 1, because I'm dividing by 2, and 2 divided by 2 is 1. And kind of an easy way to check your answer is, to see if you did this right, is to distribute back through. And if I distribute back through these, oops, if I distribute back through, do I get back what we started with? Well, yeah, there's 8 times 2 is 16x squared minus 2x. Okay? So again, we're just dividing out the greatest common factor. Look at the one right below it. Okay, and 8 and a 4. What's the biggest number that goes into 8 and 4? And it's a 4. Okay? Do they have any variables in common? Well, that has an x and that has 2 x's. The most I can take away is 1. Okay, when you have these exponents, really it's the smaller of the 2 exponents that you can divide out. Okay? Well, 8 divided by 4 is 2. I'm taking one of these x's away, so I'm left with just 1. Okay? 4 divided by 4 is 1. X divided by x, I'm taking everything away, and it turns into a 1. Okay? Oh boy, what if it had 3 terms? Okay, well, let's look at the number part. A 25, a 10, and a 5. What's the biggest number that goes into all 3 of those? Okay, well, I think it's a 5. Okay, the only thing that can go into 5 is 5. Does 5 go into 10? And does 5 go into 25? Yes. So I'm going to take out a 5. Now let's look at letters. This has x squared. That has 2 of them. This has 1 of them. But that little 5, it doesn't have any x's. So, yeah, these two have some x's, but that one doesn't. So are we allowed to take out an x then? Because not every term doesn't have an x. So in this case, the only thing I can take out is a number. I can only take out a 5. Well, let's divide each of these by 5. 25 divided by 5 is 5, and the x squareds are still there. 10 divided by 5 is 2, and it still has its x. And again, when I take away everything, it turns into a 1. Okay? So sometimes it's just a number that you can take out. Okay? Maybe not any x's, any variables. We're going to look at this guy right here, a 12 and a 10. Okay? Well, what goes into 12 and 10? Well, 2 does. Is there anything else? Is there a bigger number that goes into 12 and 10? Yeah, I think Actually, no, there isn't. Huh. The only thing I can take out is a 2 in terms of numbers. Okay, how about any letters? This has an X and that has a Y. They don't have any letters that are the same. Nope. So again, I can only take out a 2. Well, 12 divided by 2 gives me 6, and the X is still there. 10 divided by 2 is 5, and the Y is still there. Okay? Okay? So there's a couple examples of taking out the greatest common factor. I have one more down here at the bottom. That's a little bit fancier one. This guy right here. Okay, now holy smokes, look at that. That has 3 different terms to it. Okay, a couple different letters in there as well. Okay, well, let's look at the numbers. 8, 20, and 4. Okay, what's the biggest thing that goes into all 3 of those? And if you're not quite sure, look at your factor sheet. 8s, 20s, and 4s, different factors. And if you look carefully, I think the biggest number that you'll see that's a part of all 3 of those lists is a 4. So I can take out a 4. Okay, now let's look at the letters. I have A's and T's, but does every term have an A? This one has 2 A's, that one has 1, and this one has 1. What's the most number of A's that I can take away from each individual term? The most I can take is 1. So I'm going to take out 1A. Okay, and how about T's? If I look closely, this one has 2 T's, that has 2 T's, but that one only has 1. So again, the most I can take away from all 3 of them is 1 of them. So I can take away 1 T. Okay, so there's my greatest common factor, 4, A, and T. Okay, so let's divide each term by a 4, an A, and a T. Well, 8 divided by 4 gives me 2. I'm taking one of the A's away, so I'm going to have 1 left over. And I'm taking one of the T's away, so I'm going to have 1 T left over up there as well. This a little bit bigger. Okay. How about the middle term? 20 divided by 4 gives me 5. I'm taking the A away, so there aren't any A's left. I'm taking one of the T's away, so there's just a T left. Okay? I'm dividing 4 by 4, it leaves me with 1. And you can write a 1 there, you don't necessarily have to. But I'm taking the A away, and I'm taking the T away. So I end up taking everything away, which we know turns into a 1. And there's my answer for that one. Okay? So it doesn't matter if there's 1 terms, 2 terms, 3 terms. Well, it has to have more than 1, I guess. But 2 terms or 3 terms or 4 terms, if every term has something in common, we can factor it out. And that's what's called the greatest common factor. Okay, so that's one thing that we're going to be looking at today. Okay? Look at these. Okay, oh, these look kind of complicated. Okay, but let's look at this first one in the top left up here. I have one term, a 5 and an x plus 3, and a 3a and an x plus 3. Do those 2 terms have something in common? Okay, and if you look carefully, they don't have any numbers in common, but they have a little expression in common. They both have an x plus 3. Okay, so little expressions can be greatest common factors as well. I'm going to take that away from both of them, and I'm going to factor that out in front. I'm going to take an x plus 3 away. And if you look closely, what's left over? I have a 5 and a 3a, 5 plus 3a left over. Okay, but once again, here was the greatest common factor. It's a little expression this time, and we're going to use that in a few minutes in the next thing. Okay, if you look carefully at these 2 guys, if you look closely, they both have the expression y minus 2. So I'm going to take that away from each one and factor it out in front. Okay, again, it's going to be its greatest common factor. And if you look closely, what's left? I have a 7a minus 8. And there's the leftover pieces. Okay? Yeah. And there's one more down here at the bottom. How about this one? If I can make it come a little bit bigger here. Here we go. Oops. Okay, how about this guy? Leave those up there. Okay? What expression do these have in common? They have a 2y minus 1 in common. So I'm going to cross them off, and I'm going to factor it out in front. And by crossing it off, I can see that I have a 4x plus 5 left over. Okay? So again, that greatest common factor can be a number, it can be a letter, it can be numbers and letters together, and also it can be little expressions like these guys that we can take away. Okay? And again, all we've done so far is we've factored out the greatest common factor. Okay? Whew. The next thing we're going to do, oh, here's a special one. My bad. Okay? Look closely now. Oh, they kind of look the same, but they're a little bit different. this is an x minus 3 and that's a 3 minus x. It's not the same. They're not the same. Okay, well, what could I maybe do with this second one to maybe kind of make it look like that one? Because this one's kind of the weird one. It's kind of written in reverse. Well, what if I left this one the same? And in the second one, what if I switched the order? And I put the x first. It would be a negative x plus 3. Okay, now it's looking closer to that. And this is kind of a big thing here. It's looking closer to that, but the x is first, the 3 is second, but the signs are different. Okay? This is a positive x and a negative 3, and that's a negative x and a positive 3. Well, there's something that I can do with this one. What if I divided out a negative 1 out of this? Okay? That would make that become a positive x and a negative 3. Okay? And negative 1 times the a would turn this into a minus a. And the first part's going to stay the same. So what I did is I changed the order and I factored out a negative sign. Okay, and now if I look closely, the little expression on both of these little terms is the same. And I'm going to factor that out as my greatest common factor. So they're gone, and if you look closely, what's left? 5 minus a. Okay, you're not going to see this a lot, but every once in a great while we're going to see ones where the terms are kind of, they look the same number, they have the same numbers, same variables, but they're reversed. Most 99% of the time we're going to change the order and have to factor out a negative 1. So just be cautious of that as we do these. Okay? All right, here's a new thing. Okay, so up until now we've taken out a greatest common factor out of each term. Okay, well here's another method. And if you look closely at that, there's 4 terms up there. Okay, there's 1, 2, 3, 4. And all 4 terms do not have a greatest common factor. It doesn't look like it. Okay? Yeah, there's nothing the same that's in all of them. Okay? Well, there's this method of factoring called grouping. Factoring by grouping. And when do you know you have to use grouping? Is when there are 4 terms. 1, 2, 3, 4. That's the big clue that we're going to do grouping. Okay, we're going to look at a couple different kinds of factoring here in this chapter, but this is the first one called grouping. Okay, and the way that grouping works is pretty simple. Okay, we're going to group numbers together, and we're going to group 2 at a time. And the way it works is we're going to group the first 2 numbers together and the last 2 numbers together. Okay, notice how I left the plus sign in between them. But we group the first 2 and we group the last 2. And then what we do is we're going to do what we did a few minutes ago, is we're going to look at each group and try and factor out their greatest common factor. And if you look carefully here, okay, I don't think the 2 and the 7 have any numbers in common, but each of them have an x. So I'm going to take out an x out of that first group. And if I take away my x's, looks like I have a 2y plus 7 left over. Okay? If I look at this one, 2y plus 7, they don't have any greatest common factors. They don't have anything in common. It's just going to stay 2y plus 7. Well, hey, this kind of looks like what we saw a couple minutes ago. Do these guys have anything in common? Yeah, now we're going to take out that expression. They both have a 2y plus 7. So I'm going to take that out, and sometimes I go like this. I'm going to take that away from both of them. And when I do that, I have an x plus 1 left over. Okay? And we'll practice a couple more here in a second, but that's how grouping works. It's when there's 4 terms, we group 2 at a time, and then factor out their greatest common factors. And in grouping, what we're going to have is we're going to have that little expression that we're going to take out. Okay, and put out in front. Okay, here's another one. Okay, if you notice carefully, there's 4 terms. Okay, so I'm going to group the first 2 and the last 2. And notice I have a plus sign in between here. We like that when it's a plus sign. And I kind of leave that separate. And I kind of do this. When I look at the first term, do they have a greatest common factor? A 15 plus 3ab. Well, with 15 and 3, I think 3 goes into both of them. So I can take out a 3. And they also have an a. Okay? If I divide this by a 3 and an a, I just get a 5 left over. And if I take the 3 and the a out of this, I just have a b left over. So I have a 5 plus b. then I see my plus sign. Now let's look at this one. 4b plus 20. Now, this one, I think they do have a greatest common factor. I think a 4 goes into both of those. So if I take out a 4, what I have left over is a b plus 5. Okay? And when we do this grouping thing, we're looking for the stuff in the parentheses. We need them to be the same. Well, is b plus 5 the same as 5 plus b? I think so. If I change the order on these guys, okay, the b is still positive, the 5 is still positive, they end up being exactly the same thing. Okay, so now I can take these two things, I can write them out in front. That's what they have in common, and I can kind of cross them off. And if you look closely, what's left over? A 3a plus 4. And I got it factored again. And again, factored means breaking apart into different pieces. I started with 4 separate terms, and I factored it into 2 terms, 2 little binomials. Okay, let's try one more of these. Okay, this one's a special one. Now, what's special about this? Okay, it doesn't look any special. There's 4 terms. Okay, what I want to point out here is, if I was to group these in parentheses like this, I want you to notice what sign is in between them now. There's a minus sign. And that's what's special. Okay? And I want to show you how that makes a difference here. Before I put the parentheses around there, look at the signs of my numbers. The 2p squared is a positive. That's negative, and the 27 is negative. Especially the 18. It's a negative 18 and a positive 27. But when I put in my parentheses here, okay, those things, that still stays positive, that stays negative. Remember now, there's a negative 1 in front of that group. There's a negative 1 in front of that parentheses. And if I distribute it through, it makes the 18, it still stays negative. But what does it do to the 27? Negative 1 times 27 makes it negative 27. Okay? So what we just did here is we changed the value of the 27. To make a long story short, here's what we need to do. When I group these things together, and I have a minus sign in between the 2 groups, we need to change the sign on the very last number, just the last number. So instead of a positive 27, that needs to be a negative 27. Okay, now if I take that negative and negative, if I multiply that negative 1 times a negative 27, it turns it to a positive 27. And then we're in business. So again, if there's a minus sign, change the sign on the last one. Now let's do my grouping thing. Is there something that this group has in common? Well, I think they have a p in common. And I can take a p out. And if I do that, I get a 2p minus 3. There's my minus sign. How about this group? What do they have in common? 18 and 27. If you look carefully, whether it's at your factor sheet or you know your times tables pretty well, there's a 9 that goes into both of them, and just a 9. So I'm going to take out a 9. And 18 divided by 9 is 2 with a p. And then negative 27 divided by 9 is negative 3. And if I look carefully at the grouping, the stuff in the parentheses is now the same. Okay? And if you forget to do this change up here at the beginning, you'd have the wrong sign right here, which means, oh yeah, shoot, I forgot to go back. We got to make it a negative 27. Well, they both have a 2p minus 3 in common, so I'm going to take that out in front. And I'm going to factor it out. And when I factor it out, it's gone. And if you look closely, I have a p minus 9 left over. And there's my answer. So factoring by grouping, when there are 4 terms, and we're going to see a few of those today. When there's 4 terms, that's when we have to do the grouping. But group the first 2, group the last 2, look to take out the greatest common factors. And remember, you can always go back and watch this video again. Okay? All right, we're getting closer here. We're narrowing it down. Lastly here, it wants us to solve by factoring. Well, for today here, they're going to start out, these are already factored for us. They're in what's called factored form. And I want to solve it. And you guys know what solving means. We want to find the value of x that makes that equation true. Okay, well, what I have here is I have 2 things being multiplied, 2 little expressions being multiplied to equal 0. And you guys know a little bit of something about multiplication and the number 0, and that's anything times 0 is 0. So if I have two things multiplying together to be 0, that means one of two things. Either x plus 3 has to be 0, or x plus 8 has to be 0. One of those two things has to be true. Okay? Well, if I solve for x by subtracting 3, x could equal negative 3. And if I solve this one by subtracting 8, x could equal negative 8. Okay? And to do a little check here, if I plug it back in, negative 3 plus positive 3 is 0, and 0 times anything is 0. And same thing if I plug in negative 8. Negative 8 plus 8 is 0, and anything times 0 is 0. Now there's a little bit of a shortcut that we can use. It's not too hard, not too bad to write these as two separate equations and setting them equal to 0. But many of you might see a relationship. Is there a relationship between x plus 3 and the answer being negative 3? And the solution x plus 8 and the answer is negative 8. There's a relationship there. The solution is the opposite of whatever's in the parentheses. Okay? Now I'm going to just do one more here. What if I had this one? If I had x plus 5 and x minus 7 equal to 0. I'm hoping that I can skip this step of having to write these two equations and just look at it. And we're going to do a lot of factoring where we're going to just look at it. X plus 5, the answer would be negative 5. X minus 7, it's going to be the opposite. The answer would be positive 7. Okay? So I'm hopeful that we can just look at that and get the solutions. And I have a couple here on the next page that we're going to take a look at here. Hey, can you help me solve these? X plus 1 and x minus 9. This one should be negative 1, and that one should be positive 9. This guy here is negative 6 and positive 5. Okay, again, it's the opposite of what it looks like in the parentheses. Okay? Holy cow, look at these. Now these, it's really the same thing. Okay? But there's more stuff in the parentheses. Well, I'm going to do the same thing once. Watch this. I'm going to set it equal to 0 to start with. And this one could be 4x minus 8 could be equal to 0. Well, if I solve it, I'm going to subtract 6, which is negative 6 divided by 2. And that's going to be negative 3. Okay, this one I'm going to solve it by adding 8, and then divide by 4, which is 2. Okay? Okay, what I really want you to see, is there a shortcut involved with this as well? Okay, yes. If I look at 2x plus 6, if I took away the 2, many of you guys would say negative 6, which is right. But how did I go from negative 6 down to, negative 3? What did I do with the 2? We ended up dividing by the 2. Okay, so here's the shortcut with these. It's the opposite of the last number again, and some people like to cover up the number in front of x, but it's negative 6 divided by 2, which is negative 3. Over here, if I cover up the 4, it's positive 8, and there's my 8, but then I had to divide by 4 to get positive 2. Okay? Let's see if we can use a shortcut over here. Without having to write those two equations, if I cover up the 5, I get positive 10, but then I divide by the number in front. So I get 10/5, which is 2 again. This one, if I cover up the 3, I get negative 7 divided by 3. Negative 7/3. And it doesn't always come out to be a nice number. Okay? And that's okay. Okay, but I'm hopeful that we can skip all this equation writing stuff. And the more you use this, the more you do it, the easier it's going to become. And we're going to do it a lot. Okay, so I like to practice it right out of the gates here. Okay, but these first two, when we have stuff in parentheses again, it's the opposite of the second number divided by the number in front. And really, if I go back a second, these are the same thing. It's the opposite of 5, and there's a 1 in front. Well, what's 5 divided by 1? 5. Negative 6 divided by 1 is negative 6. So it's really the same thing. We're just dividing by 1 when there is no number out there. Okay? All right, these two down here at the bottom. Okay, these are, again, along the same lines. But I have two things multiplying together to be 0. Either 5x equals 0 or x minus 3 equals 0. Well, I know from this one, I could get positive 3 if I add the 3. And I'm hoping I can even skip this. And you can look at it in parentheses. If it's x minus 3, the solution is 3. But what about when there's an x out in front? 5 times what number is 0? Well, if I divide by 5, x is 0. Okay, and there's kind of a little bit of a shortcut here as well. When there's an x out in front that's not in parentheses, the solution is 0. Okay? What if I did this one right here? I have a 6x. Well, there's an x out in front. X is 0. And if I tested it, 6 times 0 is 0, and 0 times anything is 0. It works. What if I use my shortcut here in the second one? Can you see it? It's the opposite of the last number, which is 2, divided by the number in front, 2/3. So again, I get 2 answers again. Okay? And again, these are already factored for us, which is nice. Okay? All right, here's the last thing for the day. Okay? Can we put this all together? Can we solve an equation by factoring with the greatest common factor and using our little solving rules here? Now, in order to solve each equation, and we're going to do this by what's called factoring, we always need to have a 0 on one side of the equation. Okay? And a lot of these, when we do these, they're going to have an x squared term, and I always like to keep that x squared term positive. Okay, so with that being said, I'm going to move the 40x over to the other side. And I'm going to set it equal to 0. So sometimes we have to rearrange it, but I like the x squared term to remain positive. Okay, now let's think about what we did way, way, way back at the very beginning. Do these guys have a greatest common factor? Is there something that goes into 8 and 40? And I want to find the biggest number that goes into 8 and 40. And if you look at your factor sheet, I think it's 8. 8 goes into 40. And they also have an x in common. This has 2 of them, this has 1. Well, I can take one of them away. So I can take out an 8 and an x. And what's left over if I take out an 8 and an x? I have an x here, and 40 divided by 8 is 5, and my x came out in front. So that one factors into 8x and an x minus 5. And if I know, or if I use what I did just a few minutes ago, can we find the 2 solutions? Whenever there's an x out in front, it doesn't matter what's in front of it, an 8x, a 9x, a 2x, but if there's an x out in front, 0 is a solution. And this one here, x minus 5, the solution is positive 5. Okay, so this is kind of tying all of that stuff all together. Hey, I think I have 3 of them here that I'd like to try. Okay, can we try the second one? Now the second one here is kind of out of order. Again, there isn't a 0 on one side. And if I look closely, the x squared, the biggest power is negative 16. I want that to be positive. So again, I'm going to move that over to the other side. I'm going to go over here so I have a little more room. I'm going to make that be positive 16x squared plus 32x equals 0. Okay? Now let's look for a greatest common factor. If you look at 16 on your factor sheet and 32 on your factor sheet, you notice the biggest number that's on both lists is 16. So I'm going to take out a 16, and they also both have an x in common. So I'm going to take out a 16 and an x. Okay, and when I do that, okay, 16, I just have an x left over there. I'm taking all of 16 and one of the x's. 32 divided by 16 is 2, and my x came out in front. And once again, I have 2 solutions staring at me here. There's one, and here's another one. The hardest part is getting it factored. You'll see as time goes on here, the easy part is going from here to here. Well, again, there's an x out in front, so 0 is the solution. And the opposite of positive 2 is negative 2 is a solution. Okay, good. Okay, all right, here's the last one for the day. Can you, see if you can take a second and try this one by yourself. Maybe you can push pause and then unpause when you're done. Ready, set, go. Okay. All right, hopefully you tried it. Let's give it a whirl. Well, I need to get a 0 on one side. The squared term is on the left, so I'm going to move the 4a over to the left, and so that my a squared stays positive. And I'm going to subtract 4a. They have a greatest common factor. Now, they don't have any numbers in common. Okay, this has a 4. That doesn't have any number, but they both have an a in common. So I can take out an a. I'd have an a minus 4 left over. I'd have one a and then just the 4. Oops. And then I have my 2 solutions staring at me here. when there's just a variable out in front, 0 is a solution. And a minus 4 would turn into a equals positive 4. Okay? All right, very nice. There we have it. So we did some things with a lot of stuff with greatest common factor and factoring out the greatest common factor. Okay? And then the other thing we're concentrating on today is this stuff right here, finding the solutions. Okay, once it is factored, it's just the opposite of the number that's on the inside. Okay? And when there's more stuff in the middle, it's the opposite of the last number divided by the number in front. The opposite of 7 divided by 3. Okay, we're going to continue to work with factoring and solving by factoring in lessons to follow. All right, thanks for tuning in.